When you start laying out your receptacle and lighting outlets in a building, the first thing you need to do is first lay them out, right? So step number one for design, I'm going to say design. For the design in a dwelling, step number one is going to go lay out. You need to lay out two things. You need to lay out receptacle. I think it's Monday, huh? And you need to also lay out lighting outlets. We need to find where do we need receptacles in the house and where do we need the lighting outlets. That's step number one when you design the things. Now we're done with this. Next, you need to do circuiting. Same thing. You need to circuit receptacles and you need to circuit lights. Okay, so we did the layout of the lights and receptacles. We need to circuit them, right? So that's basically what we do in any design system. With this, also I'm going to add, you guys are familiar with these ones. Also there's equipment. Equipment need to be circuited and also equipment here. So we need to lay out the receptacles, lay out the lights, lay out the equipment, and everybody knows what layout is. On a piece of paper, show where they should be located. And then we need to circuit them. Then you're done. That's what a designing system is. So these are the sheets E1 through E12 that is going to walk us through how to design a system. The single most important thing when it comes to layout is the rules. Now, Matt, you're looking at me, you have a house. How are you going to lay out the receptacles in a house? There is a trillion ways of laying a receptacle in the house. Luckily, NEC code book, guys, Article 310, for these two in particular, Article, I'm sorry, not 310, 210, when we talk about NEC 210, 210 will walk you in details where do you need to put these receptacles. That's it. That's called the branch circuit. 210 in particular for dwellings and non-dwellings as well. In particular, for dwellings, 210.52. I'm going to write directly 210.52. This section, this is a dot, believe it or not. 210.52 give you all the rules that you need to lay out receptacle outlets and lighting outlets in a dwelling, as well as also circuiting. So when it comes to circuiting the receptacle and the lights, 210.52, all the information that you need is there. When it comes to the equipments, guys, equipments are scattered all over. For example, if you have an AC unit, you're going to go to Article 4. We're going to go to Article 440. If you have a sump pump, we're going to go to Article 450. So there's a lot of places for equipment. There's a lot of articles that tells you how to circuit, especially circuited, how to circuit these equipments. So for equipment, I'm going to say just NEC here, different articles. Location of equipment, layout is location. It is typically for location of equipment, guys, typically owner. Owners are the ones who decide where the range is going to be located in this room. Do I decide where the range? With conjunction with the builders and the architects, typically, they decide where the range is going to be located, where the AC unit is going to be located. A lot of these equipment, sump pump is going to be located. Do we decide where the sump pump is going to be located? They tell us there's a sump pump right there. What do? We go and have a dedicated circuit for it. Any comments, any questions about the concept of design? The concept of design, first, you need to lay out receptacles, lights, and equipment based on NEC 210.52, layout and circuiting. Then we need to circuit them. And that's what you guys are going to be doing with your friend Chad. Any comments, guys, about these concepts before we go ahead and start? Now we're going to spend some good time today talking about these two concepts, receptacle and lights, layout and circuiting. receptacle and lights, layout and circuiting. How do you lay out a receptacle and lights? And I'm gonna get you a very simple house here, room. Here's my room. And when I say layout of a receptacle, guys, you come over here. Here's receptacle 1, receptacle 2, receptacle 3, receptacle 4. So Karen, if you, when I was doing wiring in Jerusalem, we didn't have the LEC code book. When I walked into a room, here's rule of thumb, rule of thumb, without knowing the code. You walk into a room and you throw receptacles in it. Throw one single receptacle in the middle of every wall. Done. Done. That's rule of thumb, right? So when you guys start laying out receptacle for chat, the first thing you're going to do, every habitable room, the code says, our code here says, every habitable room need a receptacle within 6 feet of every opening. These are the rules. So how do you start? You start throwing a receptacle in every center of every wall. Now, some of you would say, Chad, where's the center of this wall? There's a door. Pick a location. If you have a receptacle, would you put the receptacle behind the door or here? Typically here, because you don't want the door to close over it. So that's the concept of receptacle layout without knowing anything. So that's layout of receptacle. Layout of lights. If you have a room in a house or a Dunwoody, when you lay out lights for a habitable room, very simple. You put one light in the center of that room unless you're told otherwise. Did you guys hear me? Okay, so Matthew, you've never heard of that. Here's a light right in the center of this room. I laid out the receptacles and the light for this room. Cool. One little thing, with light comes what? Switches. Lights have to be switched. Wall switches. So what we do, we use a symbol like this that indicate that light switch is going to be controlling this light. Can you have thumbs up, Chad? That's piece of cake, right? So forth. So I laid out my receptacle, one receptacle in the center of every room. I put my light in the center of the room. I put a light switch to control that light. I'm done. Especially Matthew, because I know you finished one semester with us. Does it make sense? If it makes sense to you, because you didn't do, some of those guys took some other wiring methods. So does it make sense? Cool. Now suppose that I have a window air conditioning in this room. You don't have to. I want to put a window air conditioning. So there you go. I'm going to go grab a window air conditioning and put it right in here. This is AC unit. Okay? And I want to put a special plug for this AC unit right here. Something like this. I think we do a special plug. So you can plug it. Now, who's going to decide where the AC is going to be located? The customers. They have to tell me that they want a window air conditioning, right? And so here's my equipment here, window in this room. Here's my light. Here's my receptacles. I laid them out. The receptacles based on the center of every wall, the light in the center of the room, the equipment based on where the customers wants to put their AC. They told me they're going to put it in this wall. What if they don't tell you? You can use your judgment in an outside wall and just throw it there. If they change their mind, you have to change it. These are what we typically, when we design a project, guys, when we design it, we discuss these with the customers. Where do you guys want your window air conditioning? Do you want a central air? Okay. Any questions, guys, about the layout? The last step that you need to do now is circuiting. We lay them out. One room. Now we need to circuit them. The question that you need to do when you circuit is, and especially in dwellings, do I want to circuit the receptacles and the lights and the equipment all in one circuit, or am I going to separate them? 99% of the time, design projects, we separate light from receptacle from equipment. Do you guys hear me? We separate light from receptacle from equipment. So when you walk in, now I want to circuit them. I want to go spaghetti them. We call it spaghetti. So I'm going to come from here, tie these two together. Can you guys see that? That's what you're going to do with me today. I mean, this week, from here to here. And I take a home run, and I'm going to go circuit number 1, P-1. So circuit number 1, P-1. Let's put it right here. Circuit number 1/P-1. So this is what we call a home run that take these. Oh, I forgot there's another receptacle here, so I'm going to grab that receptacle. I grab these 3 receptacles and put them in circuit number 1, panel number 1. Ladies and gentlemen, you're done with laying out and circuiting a room. You're going to do it in CAD now, right? I showed you the symbol. You're going to go drop it. Does that make sense, Matthew? Now, why didn't I put the light on it? Because I told you 99% of the time, if you're designing a project, you separate the light from receptacle. If you're doing a house, a little house, they mix them up. But for design project that we're concerned with, light and receptacles are separated when it comes to home runs. When they say a home run, a home run, the circuit is right here. Yeah, so we'll go land it on a circuit. So this is circuit for receptacles. Now we're going to, and you guys, and I use the color blue. The color will indicate a layer for you. Guys, remember the layers that we were working with last week? That's why the color is going to be a different layer for you. So when you turn them on and off, only the power will turn on, only the power will turn off, or the light, depending what you want. Okay. Now lighting fixtures. For your lighting fixtures, the only thing you have is only one light. So you're going to go from this light to the switch. From the switch, I'm going to take a circuit number. So we're circuit number 1 here. I'm going to take circuit number 2, panel number 1. P-1 is panel number 1. In most of buildings, they would have multiple panels. In the apartment building that we have, we're going to have one panel in every apartment. So the apartment 1 will P1, P2, P3, P4, and P5 is for common loads between all the panels. Four panels. You need to identify where is this circuit going. Is it going to panel 1 or 2 or 3 or 4? If you have only one panel in the house, do you need to identify the panel? No, it will be redundant. So I took my lighting circuit, the red, and I grabbed it all the way to the same panel and put it in circuit 1, circuit 1, circuit 2. Put it right here. 1, 2, 3, 4, 5, 6, 7, 8. That's how we go. From left to right, when you do the circuit. From left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you keep going. The last thing, my friends, that we need to do, that window air conditioning need to be circuited. I can't, in a designed residential project, I can't emphasize, designed residential project. You're talking about apartments, bigger buildings. You don't mix the window air conditioning on the other circuit, the receptacle. You could have a 120 window air conditioning, plug it into the room. Bad idea. You know, we have a dedicated receptacle for that window plugged in window air conditioning. I have it here, so I have my window air conditioning. My window air conditioning, though, do you guys want to do it 120 or 2? You have two options. You have a 120 or you have a 240. Shall we make it 240 for the heck of it? Let's make it 240. If it's 120, it will look like this. It will be circuit number 3, panel 1. But let's spice it up and make it 240. So then it becomes circuit number, okay, now 240 need 2 poles. You're looking at 2 poles, 2 huts. These 2 tied together, right? Then when you show them up, and they have to be, in order to get 240 from a panel, they have to be either adjacent odds or adjacent even. So only way you can get 240. If you go 1, 2, that's 120, both of them. 1, 3, 240. 3, 5, 240. Adjacent odds. So the panels sit like this, guys. Here's your adjacent odds, here's your adjacent evens. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 circuit breakers in the panel. If you want the first, this 1 and 2, that's how they label. 1 and 2 are all 120. 3 and 4, 120. 3, 4, 5, 6, also 120. To take it to the neutral. Can't take 240 between them. In order to take a 240 circuit, what do you need to do? Either adjacent evens or adjacent odds. So you're going to take the 1, 3, or 2, 4. Or you take these two together. Any 2 adjacent, these, or these. Are you guys following with me? 2 adjacent odds or 2 adjacent evens to get you 240. So I'm sitting at circuit 1 and 2. Now 3. My next circuit is going to be 3. So 3, comma. I'm going to take 240. Can I do 3, 4? No. So it has to be 3, 1. 3, 5. Thank you. So 3, 5. Gentlemen, you have just circuited this room. And in your panel, so that's your, of course, coming from which panel? Panel -1. So when you come to your panel, here's your panel right here. Here's my main circuit breaker. Here's circuit 1, circuit 2. Oops, there you go. So I'm going to label them with this. So this will be my 1, 2, 3, 4, 5, 6. These are, and keep going all the way. You have 30, in Woolings we have a 30 amp, we have a 30 circuit breakers and a 40 circuit breakers and 20 circuit breaker panels. So I'm up to 5. So circuit number 1, guys, for the, can you guys see the circuit number 1 for the receptacles will be coming from here? Circuit number 2 for the lights will be coming from here. Circuit number 3 and 5 are going to be coming from right here together. And by code, you have to tie these two together. Anybody knows why we tie them together? Because they're giving me 240. You take the 2 circuit breakers, put on a pulled handle, tie them, and then you feed your air conditioner. Now, what happened to 4 and 6? In this project, there's space, either space or spare. Spare is you put the circuit breaker inside them. Space is just room. We have room in space. We have room. This is space. This is space. This is space, right? But any one of these could be a spare. Spare is just circuit breaker sitting there doing nothing, not connected to anything. Any comments, guys? Any questions? This is the concept of designing a room. Now, if you have 16 rooms of these, would it be different? Absolutely not. The question would be, Derek, my friend, then how many lights can I put on a circuit? How many receptacles can I put in a circuit? Can I combine receptacles of different rooms in the same circuit? Absolutely. Can I combine lights of different circuits on one, of different rooms on one circuit? Absolutely. Can I combine equipments on one circuit? Not a good idea. Typically, if you have an equipment, dedicated circuit. Equipment, dedicated circuit. For light and receptacle, then we start adding, we start connecting these lights and receptacles in multiple circuits. So if I have another room here, we can add more receptacles. How many receptacles and how many lights? We're going to talk about this one in a second. Any comments, any questions about the concept of layout and circuiting? So that's what this book, guys, is talking about. Laying out and circuiting your equipment. Laying out and circuiting. Does it make sense? Yes, no? You guys, I know you did some circuiting with us there. The only thing you're going to do different here, you're going to use CAD. Make it look nice, circuit it properly based on the design, not based on minimum qualification, minimum code requirement. When we're designers, guys, we use minimum code requirement first. Then we go slightly above it, knowing that we went above it. That's why they hire you, because you're above the code. Otherwise, they in a house, they might as well give it to an electrician, go lay it out. You think electricians don't know how to lay out? They'll lay it out. They might not know how to do the CAD part of it. Any comments, any questions about laying out receptacles and lights? I will PDF this one and put it in a network for you. PDF it and put it in a network for you. Okay, so let's go to, so having said that, so here's the presentation that we're going to be doing, guys. Determine the required number of lighting outlet, receptacle outlet, and small appliances circuits, the branch circuits. So this chapter, with the information that you have in chapter 3, will help you determine how many outlets, light and receptacle you need, and the small appliances circuit and the general purpose circuit. And we'll talk about these in a second. Calculate branch circuit sizing, understand volt amp per square foot, calculate the occupied floor area of a residence. Determine the number of lighting and small appliances branch circuit, know where receptacle outlets and lighting outlets have to be. There's a few things. So before we start, now I gave you guys the full picture. The full picture is we're laying out receptacles and lights and equipment, and we're circuiting them. Now the circuit that I have just showed you is called the branch circuit. They define the branch circuit as the conductors between all these lights and the last overconduction loss, which is that one. So we take away from here, all the way and feed all these or some of these lights or receptacles. That's called the branch circuit. Any comments, guys, about the branch circuit? Derek, my friend, when it comes to the electrical code, there are 3 circuits you must understand fully. One circuit is the one that brings the power to the building. That's called service entrance conductor circuit. We brought the power to the building. Done with it. The second circuit down in the basement. The second circuit is the conductors that bring the power from the basement to this panel. These are called feeders. Cool. Now we brought the power to this panel. The third circuit is called branch circuits, and the name is very important if you guys want to stay in this business. Branch circuit is the wires between this circuit breaker and the utilization equipment, as in lights, receptacle, outlets, AC. These are called branch circuit. 3 circuits. Any comments, guys? Any questions like the parallel series circuit that you guys did? These are your 3 circuits. That's your circuit. Feeder. Talked about the feeder. The feeder. So if because I can draw from that one. Here's how I draw that one. So if you guys, here's the transformer coming from the electrical utility. You bring it to your building. You put circuit breaker here. Here's my main panel. This is my main panel. Out of my main panel, I took another circuit breaker and put it in another panel. Look how it goes. And out of this panel, which is main lugs only, I took a circuit breaker and I fed my light. I'm lighting just a light here. Or a motor or whatever. So, so what you're dealing with is this right here is called my branch circuit. Right? Branch circuit right in here between the light and the 20 amp circuit breaker. Now, this is a 100 amp circuit breaker. Between the 100 amp circuit breaker and the panel here, that's my feeder, my F, Mr. Feeder. And this is my 400 amp panel coming in. And that conductor coming from transformer is called XFR transformer. This is the transformer from Excel. This is my service entrance conductor circuit. Can you guys see it? Conductor from the transformer to the main panel is called service entrance conductors. From the main panel to the sub panel is called feeder. From the sub panel circuit breaker into the load is called branch circuit.
Yeah, the sub panel would just be like apartment rooms.
In our project, the service conductor would be coming to a meter socket inside the apartment building. From the meter socket going to each apartment, these will be feeders. Any comments, guys? Any questions? Matthew, does it make sense? So these 3, this one is Article 230, and then Nisi will talk about it. You guys are going to spend the whole year talking with Chad about this thing. Feeder is Article 215, and branch circuit is Article 210. Any comments, guys, about the difference between service entrance conductor circuit, feeder circuit, and branch circuit? Does it make sense? So that's my my circuiting requirement. Okay, ambiguity. We have a concept that's called ambiguity of conductors, guys. We'll be talking about this one as we go through. As must not be less than the rating of the overcompression device protecting that conductor. So, for example, if I have a 20 amp circuit breaker, I cannot, the conductor that can land on it cannot be smaller than number 12. And I know this is, we haven't started circuiting, but in the MEC code book, branch circuits, guys, if I have a 15 amp circuit breaker, I can't land on it more than number 14. 14 is a wire gauge. So you cannot, the conductors has to be protected from an overcurrent based on their amplicity. So the amplicity number 14 will limit it to 15 amps. The amplicity number 12 will limit it to 20 amps. Any comments, guys? Any questions about this one? I can't emphasize the word here, exception. Motors are exception. I know you guys have not done circuiting, a lot of you. Motors are exception. Branch circuits. So, for example, if this circuit breaker is 20 amps, what's the minimum conductor size you can let in? Minimum. Well, if this circuit breaker was 15, what's the minimum conductor size you can let in? Minimum. 14. That's what this all about. So let me list the third one because these are the most common. Number 10, number 10, I'm sorry, number 30, 30 amp circuit breaker always goes with number what? Number 10. So number 10, gauge 10. So Karen, between 15, 20, and 30, you have just wired 95% of every load in every house. That's it. You know what's left? What's left is 40. 40 amp. And that guy goes with number 8. Number 8 gauge. Number 8. Between these 4 gauges, you have wired the whole apartment that I gave you. The whole apartment will be wired with, excluding feeders and service conductor, which is just 5 feeders and 1 service conductor. Excluding that, everything will be wired with 15, 20, 30, or 40 amps. Done. That's all dwelling for you. Any comments, guys? Any questions about that? Please, as we start circuiting, when we start circuiting, Karen, you're going to ask yourself, Chad, these are the 4 options that you have in dwelling. No more. Are you using 40, 30, 10, or 20? Between the 30 and the, can I use this one without making a mess? Oh, I can. Still red. Between these 2 guys together, between these 2, you got yourself 80% of your loads. 80% of your dwelling loads, circuits, are 20 and 15 amp circuits. The 30 amp, your 30 amp here, we have an AC, and the 40 amp is for what? Range. Done. You have just circuited the whole house. Any comments, guys? Any questions about this? These are very, very important when you start circuiting. And when I say 40 amp, Matthew, I mean 2 poles, like these 40 amps. When I say 30 amps, I mean 2 poles. 30 and 40 are 2 poles, 2 of these. 10 and 20 and 15 are single poles. 1 pole, 1 circuit breaker. Any comments, guys? Any questions? You got yourself circuiting everything that you need in the house. So please write yourself a note with these circuits. These are the most important 4 circuits you're going to use in the whole apartment. A whole apartment. Basic wiring sizing, the ability of the conductors. Here's the concept that we just talked about one. Okay. Right in here, here's I would exclude this one slightly from our project, but you can use it. The branch circuit by code can go 15, 20, 30, 40, all the way to 50 amps. For dwellings, like I said, these are the 3 the 3 circuit. I like to add for this one, put 2 for 2 poles, and this one also 2 for 2 poles. When I talk about 2 poles, guys, I mean 2 circuit breakers like this. Here's my 30 or 40. When I say 15 or 20, this will be like this, 15 or 20. Does that make sense? Does that make sense to all of you? 15, 20, 30, 40 is all what you need to circuit this. Can I use 50? Not a whole lot of 50 loads and dwellings. But come to Dunwoody now. Our air handling unit, 1 branch circuit is 400 amp. Now we're a whole different animal when we go to commercial industrial. For dwellings, typically, all what you're dealing with, typically dwellings, is 15, 20, 30, 40 circuits. Now, how about a riser, an apartment riser in downtown Minneapolis that you're using for apartments? Now, would you have a branch circuits more than 40? Yes. For what? For their chillers. If they have chillers to cool the whole building, then that's a whole it becomes like a commercial building. Any comments? Any questions? Any comments? Any questions about these? I want to emphasize, guys, on any dwelling, unless they tell you otherwise. Unless they tell you otherwise, your default is which circuit? 15 amp. So when you pick a circuit, direct for your receptacles, general purpose receptacles, your default for this general purpose receptacles in dwellings by code is what? 15 amps. So the circuits that I circuit for you guys 15 amps. Does that make sense? 15 amps. Unless the code tells you 20, it's what? 15. That's the default in dwellings. Did you guys hear me? So important. If you understand it now, you're done with the whole project. When you start circuiting with chat, your default is 15 amps. And the conductor that we're using is what? Number 14-2. 14.2. 14.2 is the conductor that we're using. Romex. 14.2 Romex with 15 amps. That's my default. Unless they tell you what? Otherwise. Any comments, guys? Any questions about that? Comments, questions? So please write yourself a note, please, before we go. So this one is also with 12.2. 12.2. This one goes with 10, typically 10.2. This one will go with 8, number 8, 4 for conductors. 8.4 or 8. So we need 2 hots and a neutral. 8.3. Sorry. Oops. Now I can't delete that one. 8.3. 8.3. Why 8.3? 2 hots and a neutral, and the ground we don't count it. Ground. Any comments, guys? Any questions? This one here will be for range. This one will be AC, typically. And all these here will be recept and light. Done. You have just circuited the whole building. Any comments, any questions? So when we start, Karen, laying out the receptacle and grouping them, we're going to be using these concepts of these circuits. These concepts of these circuits. Okay, so we got our circuits. 310.15b16 give you the ampacity of these conductors, guys. We will be going through this one a lot. Table 310.15b16, the ampacity range for your conductors. Correcting factors, we'll be doing a lot of correcting factors, must be applied for high ambient temperature. Correcting factors are found in the bottom of these tables. I'll show you these tables when we get to them. The rating factors for 3 or more current conductors have to be accommodated for. So some of you, Derek and probably Matthew, did not do that one. So table 310.15, guys, B16 will give you the ampacity of these conductors. For example, number 12 can give me 30 amps under 90 degrees Celsius. Under 90 degrees Celsius, number 12 can get you 30 amps. But the code limits you. There's a difference between how much the table can give you and what the code can limit you. The code for number 12 can limit you with what? 20 amps. But the conductor itself is rated for 30 amps. The question would be, why would somebody knucklehead does that? Why would they rate a conductor for one ampacity and use it for another? Safety. If the conductor rated THH at 90, if you're using a conductor at a higher temperature than 30 degrees Celsius, the code requires you to derate. Simple as that. We'll talk about the rating, guys. So if you go in a boiler room where the ambient temperature is 45 degree, 30 degrees, 86 degree Fahrenheit. If your ambient temperature is 86 degree Fahrenheit, you're good to go, or less, you're good to go. Higher than 86 degree Fahrenheit, we need to derate. What does derate mean? Cut the ampacity, because the temperature, when I teach lighting guys on ampacity, I said, enemy number 1 of electricity is what? Heat. You take a conductor like number 14, you can make this conductor carry 100 amps if you can cool it properly. Why would heat is an issue? Heat will melt the insulation, melt the copper. So imagine having conduits with insulation being melted and copper is being melted inside the insulation and shorted and so forth. Is that what you want in a power system? Okay, so we derate. So when we derate, we cut it. Say we derate it by 0.5, then the ampacity of number 12 becomes 15 amps. And we'll talk about the rating. Darren, I don't think you guys did the rating, right? You did a little bit, yeah. We'll talk about the rating. We'll do some examples about the rating too, how to derate for the ampacity. Now that's the rating based on temperature. Now if you decided, we're not using conduit, but if you decided, here's my conduit here. If you decided to use 1, 2, 3, these are 3 hots. Hot 1, hot 2, hot 3. 3 hots. 3 hots in a circuit with a neutral, multi-wire branch circuit, say, with a neutral, and only 3 hots, then you don't have to derate. The ampacity stays the same. Now, the minute that you start adding more conductors into this cable, look at that, more than three, you have to also derate based on bonding. So the magic number, and that table will tell you what is the rating based on bundling. For example, if your conductor is number 12, back to number 12, can give me 30 amps. Now, if I grab 4 conductors, current conductors, the code says you have to cut this number by 0.8, and we'll get to this one. What's 0.8 of so 8 times 3, 24, right? Is that 24? 24 amps, right? 24 amps. Now that beautiful conductor that's supposed to carry 30 amps no longer can carry 30 amps because I jammed it in the same conduit, or by the way, or cable. It doesn't have to be the same conduit. Same conduit or cable with other conductors that also carrying current. The reason why we talk about carrying current, guys, because if it's carrying current, it's heating. It's create heat. So you're creating more heat. The idea behind you derate if your conductors are more than 3, because if it's more than 3, you have more heat. What's wrong with heat, Chad? Heat will deteriorate the insulation of your conductors. Who cares? If you don't care about your insulation being deteriorated inside that conduit and melting, you almost can smell them, and then shorts, then your power is down. If you don't care about that, then don't worry about the rating. That's what I tell the people when we do training for electricians and so forth. So you have to derate. It's the law. Any comments, guys, about derating the conductors based on bundling? We will take examples about derating. But be aware, if you group more than 3 conductors, hot conductors, or if your ambient temperature is more than 86, then you have to get into the business of derating. But what's the worst? I mean, then your conductor can carry less amps. That's what the derating is all about. Okay, general lights. Most general use receptacle outlets. Okay, so there are general light loads. Most general use receptacle outlets, not 20 amps, 12 amps. In a dwelling, we're talking about dwelling. The general lights and the general receptacles, guys, are all 15 amp circuits. Remember how I said, unless they tell you it's a 20 amp circuit in a dwelling, what's your default for receptacle and lights? 15 amp circuit, minimum 15 amp circuit. When you do load calculation, which is coming soon, when you do load calculation to find what size of a service you need, the NDC code book does require you to take 3 volt amp times the square foot of the building to size the panel. Can I pick on you? Do you live in a house? Anybody live in a house or an apartment or something? What's the square foot of your house? Just 1,000, 2,000?
Usually like 1,500.
Let's say 2,000, big house, okay? So your house is 2,000. Here's 3 multiplied by 2,000 equals 6 with a 0, 0, 0 volt amp. That's how much. Did they do it right? 3 times 2 is 6 and 3 zeros, right? This is how much volt amp is the NEC code book allocated for all your receptacles, general use receptacles, and lights. Done. Where does this number come to be? This number is from table 220.14, which we will also be using as a couple of calculations for. We'll be using calculations, especially for people. I know you guys use that, but for people like Matthew and Derek, which you guys have not used a calculation on these tables, we'll be using calculation. So now what the heck is this number here? 600 volt amp. Take your house, Derek's house, 2,000 square foot. All the lights in Derek's house and all the general purpose receptacle. Now what the heck is a general purpose receptacle, Chad? Right? Do you guys question you when you see somebody say, light? We know what light is. Easy to know. Every light in his house. But what's a general purpose receptacle? A general purpose receptacle is a receptacle that not specified in the code as dedicated to a load. That's what a general purpose receptacle is. So any receptacle that the code does not allocate a special load to it is a general purpose receptacle. Any comments, guys? Any questions about this? Comments, questions? Any comments, any questions? So we take the square foot, multiply it by this. There's another concept that's called continuous load. Continuous load is defined at 3 hours or more at 3 hours or more, where the max and maximum. I will highlight these three things. A load is defined as continuous load if it's going to run for 3 hours or more fully. For example, I have a circuit breaker here, 20 amp circuit breaker, and I have my AC unit here. My AC unit. Does the AC unit run more than 3 hours fully? Yeah, good, right? So this is a continuous load. AC unit is a continuous load. Then how much current can I pull out of this circuit breaker continuously? Can you guys see the word 80% here? So then 0.8 times 20 give me what? 16 amps. So Karen, then continuously, you shall not pull more than 20 amps out of this circuit breaker. So the load that you're feeding here, this load cannot be more than what? 16 amps. Can you put the 17 amp circuit breaker here? The 17 amp AC? Yeah, no. You exceed the rating. Any question, guys, about continuous loads? Continuous loads, and I know you're beginners, and I know you're with me for the whole year, but the more you pick out of these concepts that we use, guys, the better you will be all year. We'll talk about continuous load for commercial, continuous load for residential, same thing. Continuous load is continuous load. What's wrong with continuous load? When you have a continuous load, the circuit breaker is here. This baby here says 20 amps. If I will pull any load, like this line load, that can be for 3 hours or more, this circuit breaker cannot allow me to pull more than 16 amps out. Like, anybody knows why? Safety. When it comes to electrical, guys, there's a lot of cautions of safety. There's a lot of things that you add for the system to be safe. If it's 20 amp and you pull 20 amp out of it continuously for 3 hours or more, it will heat. And if it heats, it will trip. It will create nuisance turbine for the customers. It could arc and spark. So the smarter than Chad decided to, if it's continuous, let's derate them, right? Not push it all the way, right? So it's like your car has, most of cars have what? Like a speedometer can go all the way up to 175, 180, right? Do they go 180 miles per hour or maybe 150? Have you ever gone more than 90, maybe? Anybody? Have you guys on the highways that you can admit that you went 120 miles per hour? Can you? Why do you think they limit us on the highways to 90? There's some free highways, but for the most part, 90 is the limit. Why do you think? Why can't you let that car go 120? That's exactly what the circuit breaker. Safety. Because you go higher than 90 miles an hour, controlling the car becomes tough. With some idiots driving around you too, so you're not alone. Same thing for that circuit breaker here. He's working with a bunch of idiots in that circuit breaker with him, right? So he start heating up, and they start heating him up too. So they create problems. That's what the derating is all about, 80%. Safety. Any comments, guys, about the continuous load? Comments about the continuous load? So that's the concept of my continuous load. 220.5 lists the various voltages that we use. We'll talk about for different systems. So when you guys go there, you're going to find 240/120, 208/120. All the voltages approved. These voltages are called nominal voltage, and as the name only applies, not a fact. So I say this receptacle is 120. If you grab your voltmeter right now and measure, will you find exactly 120? You will find a 5 plus or minus 5. You're allowed to, by code, to have it a plus or minus 5%. Typically 2% on the branch circuits, but you'll find it around 20. Around 20. This number, can you guys cross this number? 95. So when utilities guys allow you to go 5%, 5 or on equipment, plus or minus 5%. Fluctuate. So not a 65, plus or minus 5%. For example, if your system is a 20 amp, I can take 5, my voltage can dip 5% on my equipment, still doing okay. By code, you can't dip it more than 2% though, on the branch circuit. So 5% dip down or up 5%. So they can be more, 5% more. So when you say 5%, then you have 1.05 times 120 or 0.95 times 120. What would that give me? 120. Can somebody give me the calculation, guys? 120. Grab your calculator, get it handy. So if you take a 120 times 1.05 equal 126. So this will be 126 volt. That's okay. Now 0.95 times 120, 114. 114 volt. That's what the voltage fluctuates. Can you guys see the upper and lower limit of the voltages? That window is okay for equipment to function. Did you guys hear me? The okay window, that's the most confusing thing because they think, especially you guys are not going to be carrying tools, but there will be a project manager walking in and said, oh, damn it, there's no 120. Equipment are rated for a window. 120 is just a nominal voltage. Okay, I'm going to give you guys 5 minutes because it's Monday. Shall we go stretch a little bit? I don't like to go more than 1 hour without giving you a break, but I really would like to go over this one. So go take a quick break. You guys and reconvene. I want to show you, we talked about show you in the NDC code. Do you guys have your NDC code book handy? Please open your NDC code book if it's handy. At 220, here's 215. Let's go to 220. When we talked about the voltages, this is 220.5, where it tells you when you do the calculation is based on the voltage 120, 120, 240, 28, 120. This is where it tells you that these are the calculation that you can base. All the calculation that we do in the NDC code book is based on these voltages, nominal voltages used in the US. So if it's other than that, then the calculation will be slightly different. Does that make sense? That's the calculation that we used, the voltages that we said. Then the table that we looked at, guys, right here, this table, general lighting loads by occupancy, it gives you the allowances, volt amp for all your lights, and if it's commercial or industrial. But for residential though, if you guys can see dwelling, can you guys see dwelling here? Dwelling units, it allocate a 3 volt amp per square foot. To allocate a 3 volt amp, dwelling units, 3 volt amp per square foot, and it has a note A next to it, A. And A is says C220.14J, right? So if you guys for dwellings, it gives you a 3 volt amp per square foot. Like that's how we calculated Derek's house, how much volt amp. we come from that particular table. Okay, and we will be doing calculation on that. Then after you do the calculation, you come to this table, which when you guys have the NEC code book, these must be labeled tables. Lighting demand for factor. There is a whole week, guys. I'm not trying to overwhelm you, but there's a whole week where we're going to be using this table to calculate the load for this commercial building. I assign a week for load calculation for the commercial building. When we do load calculation for the residential building, when we do, and the commercial and the industrial, so you guys are going to be seeing these tables 3 times later on. It's not the first time we're going to see it. You know it now, you're good for the whole year. So dwelling units, we're going to, after you do the calculation, then you allow you to demand, to cut it. Because it's highly unlikely that you and your neighbor and everybody else are energizing all these equipment at the same time. They allow you to cut the load after you calculate it. And we'll talk about this one when we reach it. Okay, so we talked about these guys, calculating floor area. The way we calculate the floor area, I have to go look at this pictures here. I think pictures are nice to where are my pictures here? I thought I had my pictures handy. Okay, so this is what a branch circuit is, guys. Just a definition. Can you see from here to here is called the branch circuit? We draw that one. Here's how you calculate the square foot of an area. If you can, so any habitable space in any dwelling or a space that adaptable for future use. Any space adaptable for future use must be calculated in the square foot. Why do we care about this, guys? So look at this. I have 56 by 36 square foot of a house or an apartment. Give me 2016 square foot. Then you multiply this one by 3 from the table, and that will get you the allowance for the lights and the receptacle. But before you do that, though, you have to subtract, deduct areas. So for example, porches not count in a house. Garages not count. Basements that's not adaptable for future use, for example, where your AC unit sits. Do you really want to go put your bedroom and sleep right next to your AC unit or your boiler in the basement? So these are non-adaptable for future use. Crawl space, if you have a basement with a crawl space, not adaptable for future use. You have to deduct all these areas. And that's what they say, deduct areas, not to be included. So you deduct all these areas based on porches, if any, garages, all this stuff. And then the area that you're supposed to use right now is 1616 volt amp. So what do you do, Derek? You take the 1616, multiply by 3. That will be the allocated volt amp light for this house. Who cares? That's how you're going to size your panel. Again, I promise you guys, we will be doing a lot of calculation. You understand it now? You take the square foot of the house, the outside dimension of the house, multiply by 3, take the square foot, multiply the length by the width, get you a square foot of the area, multiply by 3. That's the allocated volt amp for your lights and general purpose receptacles in a house. Building like Dunwoody, same thing. You take the perimeter, the outside perimeter of Dunwoody, take it. You don't multiply by 3 because it's not a house. You multiply by 3.5. That's it. We're going to be using this table for commercial, industrial, everything else.
So does that increase if, like, say, a building gets taller?
If the building is what?
Does the building grow taller?
Mean you have multiple floors?
Yeah.
Then you start adding every floor. Yeah. So first, let's start with the basement.
That would be just based on that.
Yes.
Floor, so that's
Yes. Yes. So if your house is 3-story house, you take the square foot of the basement, like a 2-story in a basement. Take the square foot of the basement, the area in the basement, the habitable for future use, offices, bedrooms, play area for your kids that you can in the future finish it, right? Included. The area that's not, for example, a sump pump area, so that's splitting here now. Your furnace area, your boiler area, that area you're highly unlikely you're going to make a bedroom right next to your furnace, right? So that area where these mechanical equipment located, not adaptable for future use. Drop them. Crawl space, garage, porches, decks, all these are not included. Cool? We're done with the basement. Now go to the second floor. Second floor, take the square foot of the second floor and the first floor, add them up, deduct what's not habitable from them, which is typically porches. If you have a porch, or balconies, these are not habitable, not adaptable for future. It doesn't count. So, and then you add second floor to first floor to basement, and that's a square foot of your house. Cool. And that's how you multiply it by the square foot. Okay, so that's what I wanted to show you before we jump into. Any comments, guys, about doing the calculation? I promise you, you guys are going to sick of the calculation because you're going to do a detailed Excel sheet calculation for Chad for this project. Okay, we went to table 220.13, guys. Deduct from the total area what's not. Look what we deduct. Porches, garages, or any unfinished basement, unused space, if they are not adaptable for future use. When you sit for your master exam or journeyman, they catch you in that one. They say, is the basement included? No, basement's not included. No, it is included. The portion of the basement that's adaptable for future use, which most of the time basements, guys, I can tell you, close to 80% of a basement can be adaptable for future use, right? You can finish a basement and play. It's not bedrooms, but it could be offices. It could be play area for your kids. That's adaptable, right? Have to take into consideration. Only probably 10 to 15% in the basement is not, which will be the mechanical area, the laundry, if you have a laundry area and so forth. Okay, here's how you do the calculation. Determining the minimum number of lighting branch circuits. That's the minimum that I don't want you guys to use it. Here's how they do the minimum. They test you on that one. Very simple, very easy. If you guys just pay a little bit of attention with your friend Chad. Let's go back to can we go Derek to your house? So Derek's house is 2,000 square foot multiplied by 3. That will give me 60, that will give me 600, right? 600, okay? Volt 10. Okay, so that's Derek's receptacles, general purpose receptacles and lights. I would use them to size the service. Now, how many branch circuits do I need in his house? For lights and for general purpose receptacles. And I emphasize the word general purpose receptacles. Very easy. You take the 600, the 6,000, okay, and divide this number by 120. Why 120? Why 120? Because the receptacles and the lights are burning at what voltage? 120. Can you guys get me the amp for that one? So that's step number 1. Step number 2, find the amps. 600, so 0, so basically 600 divided by 12. How much? 50 amps. That's all the amps for the receptacles are 50 amps. Obviously, you're not going to have a 50 amp circuit on it. What size circuit will we use? Unless they tell you otherwise. 15. So you're going to go, so you're not going to use a 50 amp. If you want to use a 50 amp circuit breaker and feed all your receptacles and lights and use number 8 conductor to feed your lights, you're good. But typically we don't do that. We use 15 amps. Then you take the 50 divided by what? 15. Anybody knows why 15? Because the circuits that we're feeding from are 15. How much is that? How much? 3.3 amps. I don't know about you guys, but there is no 0.3 of a circuit. So that will be what? This will approximate to how many circuits? 4 circuits. So your house, minimum, is going to have 4 circuits. Minimum is going to have 4 circuits. Any comments, guys? Any questions? Any comments? Any questions? Comments, questions? Does that make sense, though? Makes sense? 4 circuits. So what does that mean? Take all your lights and receptacles, divide them by 4 in your house, and then circuit them. That's minimum. Now, what we do, we go a little bit more higher than the minimum, guys, and we'll circuit them slightly more. on a 15 amp circuit, it's not a good idea to put more than 9 to 10 receptacles or lights. You know why? Because if one of them trip, you end up with the whole house, by the way, putting it on 4 circuits. 4 circuits, the whole house. Light and small receptacles. There's other dedicated circuits. So, any comments, guys, about the minimum? I can't emphasize the word minimum. I can't emphasize the word lighting and small general purpose receptacles. Okay, so that's my general lighting. Track lights. If you have a track lights um, in a house, they give them a 3-volt amp, guys, per square foot, based on 3-volt amp per square foot. So consider lights, lighting loads for residential. They are part of the 3-volt amp per square foot. You do not add. Here's what it does say. Lighting track shall not. Can you guys see the word not here? You do not add for track lights any extra load when you're doing dwellings. So for track lights, no extra load added. No extra load. Show windows. So we give 200-volt amp for show windows and track lights and so forth. They are not. You don't add them. You don't add extra. You don't add extra for them. If it was a commercial building, by the way, guys, we will add. You have to add. But for track lights and so forth, no extra volt amp. Okay, here's track lights. You give 150 shall be indicated for every 2 feet of a track light. So typically for a track lights, we take 150 volt amp for every 2 feet allocated load. That's only in commercial industrial, not in dwellings. Does not count in dwellings. Any comments, guys? Any questions about that? So later on, when you have the load calculation sheet I'm going to give you to start with, anything track lights, it's part of your general lighting for commercial industrial. Okay, now, Derek, my friend, remember that 6,000 square foot, that 6,000 that we did for your house, volt amp? Now the code forces you to allocate another 1,500 times 2 for the small, shall be indicated for small appliances circuit as well as a laundry circuit. The code guys want you in the kitchen to have above and beyond the circuits that we calculated, the 4 circuits in your house, above and beyond them, they want you to do 2 circuits for the kitchen equipment and 1 circuit for the laundry. And each one of them has to be allocated a 1,500 volt amp, so no problem. So then I add 3,000 amp here because of the 2 for the kitchen and another 1,500, volt amp for the laundry. So I can't emphasize, your laundry is going to have a 20 amp circuit dedicated, 1,500 volt amp load, and for the kitchen, where's my kitchen? Laundry, including minimum small appliances. The small appliances, that's for my kitchen. This is also going to have 2 circuits, 20 amp each, and each one of them is allocated a 1,500 volt amp. Any comments, guys? Any questions? Now, your house is going to have 4 general purpose and lighting circuits, right? Above and beyond the 4, you're going to have another 2 circuits for the kitchen and another 1 circuit for what? The laundry, okay? And we're going to have another, and each the laundry and the kitchen have to be allocated 1,500 volt amp. That's based on the NDC code book. And you can see all these articles. Can I emphasize the word shall not require not less than 2 20 amp appliances circuits for the kitchen, which goes into the countertop? There are 3 circuits in NDC code book, guys. They're called sacred cows. One of them, or one set of them, the 2 circuits in the kitchen. So in the kitchen, they give you 2 20 amp circuits, cannot feed anything other than the kitchen dining room. In the bathroom, one circuit. That's a sacred cow. Cannot feed anything out of this. These are dedicated circuit. Bam, bam, bam. Done. Has nothing to do with the 4 circuits that we calculated. One for the kitchen, one for the laundry, and two for the bath. Two for the kitchen, one for the laundry, and one for the bathroom. The bathroom ones does not have volt amp with it. Don't ask me why. Dedicated circuit. Above and beyond. But it doesn't have load though. These guys are 220 amp dedicated circuit for kitchen and the laundry, and they also have to accommodate for the load. Okay, please write yourself. Receptacle outlet circuit, 20 amp branch circuits. Very, very important. These are above and beyond the 4 circuit that we calculated for Derek's house. Above and beyond. Number 1, 20 amp circuits. You need kitchen, breakfast area. The kitchen, so you need laundry, one for the laundry. And for the kitchen and the breakfast area here, the kitchen is 2. Here you need a 1 for the laundry. These are required, 1 for the bathroom here, 1 for the bathroom. Workshop and powder room, these are, you decided to put them there. But by code, you require 1 in the kitchen, 2 in the kitchen, 1 in the laundry room, and 1 in the bathroom. Now, how many circuits are we up to must in your house? There's 1, 2, 3, 4. We have 4 before, plus another 4. Now we're up to 8 circuit must by the code. Did you guys hear me? The 4 for the lights in Derek's house and the other receptacles like the hallways and the bedrooms and all stuff. The workshop, that's if you have a workshop. If you have a workshop, now these are not code. Yeah, the workshop, typically you have another circuit to feed the workshop. The garage, no. It's up to you. I'm going by the must. Now, would it be a good idea if you have a garage to give it a dedicated circuit? Absolutely. Does the code require you to do so? No. Okay. Now, these powder room and workshop, these are up to you. But if you have a workshop, typically we have a 20 amp circuit there to feed that workshop in your basement. Okay. All other circuits are what? All other receptacles are assumed to be what? 15 amps. Can I guys get you to understand that? So for 20 amp circuits, there are 4 20 amp circuits in the house must. 4. 2 of them in the kitchen, 1 in the laundry, and 1 in the bathroom. The 2 in the kitchen have to have a load, extra load on them, 1500 volt amp each. 1 in the laundry, 1500 volt amp each. The 1 in the bathroom, no. You don't have to allocate more load to it. Okay, so these are your branch circuits. Now, knowing this, Karen, my friend, and Derek, hopefully you can take this and start circuiting your kitchen. When you guys circuit the kitchen for me, starting this week or next week, you're going to be using these rules. Okay, double receptacle has 1 switched and 1 hot. Any point? Okay, now let's talk about the rule, if you guys don't mind, about the rules of laying out receptacles in a house. Very, very important. I'm going to write them down, and if you guys want to write them down once, and you will never forget them, hopefully again. Laying out receptacles rules. I summarize them as follows. Okay, receptacle layout. Layout. Based on the code. Rule number 1. Rule number 1, guys, they call it 6 by 12. 6 by 12. 6 by 12 starts from the door, measure 6 feet, put the first receptacle 12 feet in between. Okay? Does that make sense? So 6 by 12, 1 receptacle. So you start from the door here, opening here. The first receptacle, 6 feet. The second receptacle has to be what?
12 feet.
12 feet. Keep going around. Third receptacle, 12 feet. From the last opening, 6 feet. That's a 6 by 12 room. Every habitable room, bedroom, living room, um, office, that's a rule for it. That's rule number one.
Finn, what if, it's, let's say there's an opening, that's, it's 12 feet, but to that other opening, it's less than 6 feet. You know what I'm saying? Like, so.
We're coming to this one. So the rule number one is 6 by 12. Any question you guys about 6 by 12? Get into your bedroom, measure 6 feet, put receptacle, the other feet. Now, having said that, I told this to electrician. For you guys, a designer, your start point with get into the bedroom or the living room or the dining room or the kitchen, as a matter of fact. In the center of that room, put one receptacle. One in the center of every wall. One. Then do your measurement. Do you meet these rules? Yes, check, done. You don't meet these rules, start adjusting these receptacles to meet the rules. If you understand this one, you will never go wrong with the design. Did you guys hear me? When you walk into a room, one receptacle in the center of a room. From the get-go, easy. Grab a receptacle, snap to center in CAD, bam, we done. Now we have 4 receptacles. Every room has 4 walls, 4 receptacles. Cool? Then you start measuring from this to the center of the room. Do I have more than 4 feet? Yeah, over 6 feet? Yes. Shift it slightly in. You start shifting it. Okay? Did you guys hear this trick, Adam? First you put them in the center, then you start adjusting them for this 6 by 12 rule. This rule applies to every habitable room. Kitchen, dining room, living room, bedroom, any habitable room. So rule number 2. Let's do rule number 2. Rule number 2, these are, by the way, feet. Rule number 2, 2 feet or more. You need 1. So if you have a wall like this, and the wall is 2 feet, what do you need to do for this wall? Right? A wall 2 feet or more need at least 1 receptacle. So where am I? Here's a wall between a door and a door. If that wall is 1.5 feet, do I need a receptacle? No. More than 2 feet, you need a receptacle. That's rule number 2. Rule number 3. Hallway. Hallway, 10 feet or more. Or more, you need 1. So you have a hallway 10 feet or more, you need 1. If your hallway is 1,000 feet, how many receptacles do you need? 1. Does that make sense, guys? 1 receptacle. These are the rules for laying out the receptacles in any habitable space. Very simple. Now, rule number 4. How about kitchen countertop? Kitchen countertop. Kitchen countertop, very simple. The rule is 2 by 4. 2 by 4. So on the remember, we're going on the countertop right here. So 2 feet, one receptacle here, another 4 feet here. Then you measure from here to here, 4 feet, and from here to here, 2 feet. You're measuring along the perimeter of the countertop. Done. So how rocket science that one? They're gonna pay you to do that. Believe it? Am I the only one who's excited today or what? All right. Rule number 5. A wall, the same thing, countertop. In the countertop, if you have a wall 2 feet or more, you need 1. So you have an area on your countertop kitchen, not 2 feet, 1 foot, I'm sorry, 1 foot here. 1 foot or more on the countertop. Start from right here. Countertop, 1 foot, and there's a fridge here. You have to understand. These are the rules of laying out receptacles in the kitchen. Let me go back into, so we're at 5. Let's go to 6 here. Number 6, you need one in basement. Unfinished basement. Unfinished basement, you have to have one. In the unfinished portion of the basement. So if half of your basement is finished, the other half is not finished, the finished ones don't count. You have to go to the unfinished part and put one receptacle. So unfinished basement. Number 7, outside. 2 outside, front and back. The code requires you guys to put one receptacle in the back of the house and one receptacle in the back of in the front of the house. Done. Garage. 6, 7, 8. One in the garage. 1. Shed. Shed. 1. The garage and the shed, guys. What happens if you have a shed and the shed does not have power in it? Do you have to put a receptacle? No. Garage and shed, only if you decided to bring power to your garage or your shed. You bring a light to a garage or a shed, what do you need to do now? Through a receptacle. The shed came in 2011. The garage has been there for years. Does that make sense? If you have a detached garage, do you need to wire a detached garage? No. But if you wire it, as in bring light to it, what you need to do? You have to bring receptacle. Have we forgotten anything? That's it. That's the rules of laying out receptacles in a house or an apartment. So that's and all these rules, guys, are in the book too. Like, so we laying out your receptacles. Okay, 24. All these rules I summarize it. Countertop, 24 inches. Okay, here's a good example. Oops. Good example here, especially for the countertop. Let me grab my pen. Start from here. This 2 feet, 4 feet, 2 feet, 2 feet, 4 feet. This is 4 feet from here to here, guys. Around 4 feet, 2 feet. This is, if this is a foot or more. If this is a foot or more, you have to have one. Oh, we forgot about the bathroom. That's what I forgot. If you have a peninsula, can you guys see that peninsula? You need at least one. Island, you need at least one. At least one. If you have a sink, you have to have a receptacle within 3 feet. One receptacle within 3 feet of in a bathroom. Here's the kitchen. One for the refrigerator, of course. And this is part. There will be 2 feet, 4 feet, 2 feet, if this is part of your kitchen. Any question, guys, about the 2x4? Everybody know why the 2x4 is a big deal? Can I get you guys one little thing? In the kitchen, all these receptacle has to be what? GFCI, as well as if you are within 6 feet of a sink, 6 feet of a sink, GFCI. GFCI. The only exception for the GFCI is what? No GFCI. If you have a kitchen, if you have one dedicated receptacle for the fridge, or non-dedicated, you don't have to have a GFCI. Any comments, guys? Any questions? When you circuit these receptacles, this is how the code wants you guys to circuit them. Look what we do. Grab these two. Here's here and here. Where am I here now? Okay, so I have 1, 2, and I'm going to go. So I grabbed 1, 2, and here's one circuit. Grab another one. Oh, this one and this one. Here's another circuit. 2 circuits. Remember, there are 2 circuits. Then I'm going to feed these 2 on one circuit, and I'm going to feed these 2 on the other circuit. So that's where you bring 2 circuits to the kitchen. 2 circuits to the kitchen. But the 2 circuits have to go and power equipment on the countertop. Any comments, any questions? Chapter 3, guys, has all the information that you need for laying out your receptacles. So it's so important. So kitchen, 3 things for the kitchen, guys. When you lay out your receptacle 2x4, every wall, a foot or more, need a receptacle. Any peninsula 2 feet by 1 foot by 2 feet or more need one receptacle peninsula and an island, one receptacle minimum. And then you have to bring 2 circuits to it, 20 amp each, and all the receptacles have to be GFCI. Yes. 2 feet by 1 foot peninsula or more receptacle. Okay, so that's your receptacles. So receptacle and outlet 50 and 20 amp GFCI. Draw large atomic closed washers. Draw a large amount of. If you have a closed, the washing machine, we have a circuit for it. GFCI receptacle. Where do you need a GFCI? The GFCI receptacle, guys. Remember the kitchen countertop receptacles? How about outdoor? Matthew, if you have to guess any location that has water. Outdoor receptacles. How about the bathroom? One receptacle in the bathroom, GFCI. How about countertop for the kitchen, GFCI? How about unfinished basement? Could that be wet or damp? Yeah, GFCI. So if you guys have to guess where GFCI are needed, always think, where would it be? Where's the location in a dwelling or a non-dwelling that there will be water or damp location? Basement, garages, basement, outside, unfinished basement, garage, outside, kitchen, and bathroom and sinks. If you have a bar sink in your basement, 6 feet from the bar sink, anything within 6 feet, you have to put it on a GFCI. We talked about this. Here's how you have to bring it to the outside. Now, Derek, we're dealing with apartment. Now, this is a house. Does this apply for the apartment? All the rules that I said. Does it apply to the apartment? Yes. Except the 2 receptacles for the apartment. It only applies if the apartment has a door, direct door that open to the outside. Right? Oh, thank you. The balconies. The balconies, thank you. There's the balconies and decks that came in 2011. Or before 2008. Yeah, if you have a balcony or a deck, you are required to have receptacle, and it has to be GFCI. Thank you. But for the outside, guys, the outside, only an apartment need a receptacle if it has a door that open directly to the outside. Because if you have a quad, right, and you have 1-story quad, and you have a sliding door that gets you to the outside, you need a receptacle for every apartment. But if the apartment is a main apartment like Riser, you walk in, you go all the way, you don't need a receptacle outside. So these are your receptacles. A receptacle can be single or multi-receptacle. We'll show you a couple of... okay, the last thing I want to talk about, guys, is lighting outlets. This summarized, so we know where the receptacles are, I hope. Now the lighting outlets. This is one of the best things that summarize where do you need a light in a house. Think of it. Every habitable room needs a light. Every habitable room needs a light. So here's all the in the attic. Only if the attic is accessible and only if you're using it as a storage, you have to put a light. And you can see from the attic, hallways, bedrooms, bathrooms, stairway. Stairway here, you need a light on the stairway, right? Outside, you need an outside door. In the basement, crawl space, you need a door for the service door for your garage. Service door here required a light. The service door inside your garage. So all these are required light. Now these lights have to be switched. They can be wall-mounted switch, or they can be pole chain. You guys, pole chain. Okay, so they can be wall-mounted switches or they can be pole chains. There's places where they have to be wall-mounted. Lighting outlet must be a switch control. Switch control. All these are switch controls. The definition. There's one of them. They can't be a pole chain. Where did we go? What's that one? So a permanent stairway. If you have a stairway like this, 6 steps or more, they require you to put 2 switches. One at the top and one at the bottom. Did you guys hear me? If you have a stairway and the stairway is 6 steps or more, then you have to have a switch, a 3-way switch. One at the top, one at the bottom. 5 steps or more, do you need three-way switches? No three-way switches needed. Okay, any comments, guys? Any questions? In the kitchen, there's little issues in the kitchen and in the bathroom. Kitchens and when it comes kitchen and bathrooms, guys, can I have a switched outlet as my lighting outlet? Yes. Can I have it in a hallways? Yes. Can I have it in a bedroom and living room? Yes. Can I have it in a kitchen and a bathroom? Switch outlet, you plug in a light here and you turn it on and off. This is approved everywhere except in a kitchen or a bathroom. Typically, we don't do them. Any comments, guys, about the location of your lights? Location, you can see it. Every room by code has to have a light. That's a bare minimum. Obviously, when you guys do the design, you're going to do higher than that. So if the steps are 5 steps, good idea to put three-way switch, even though the code says 6 steps. Any comments about the layout of your lighting outlets? Everybody knows what a lighting outlet is? Outlet, receptacle outlet is for receptacles. So that's my receptacle outlets and lighting outlet. Let me disregard, go to a couple of pictures and then I'll let you go. Okay. There's one little thing, guys. The circuit in the kitchen circuit. I don't know if I can draw here. Oh yeah. Here's a 20 amp circuit that feed the kitchen. The kitchen circuit cannot feed anything else other than kitchen receptacles, not even lights. Kitchen receptacles and dining room receptacles. There's an exception if you have a clock. You can, in the kitchen, you can feed that clock. They don't use wired clocks anymore. If you have a clock, you can use it. Or if you have a range, a gas range. Gas range, you need a 120 for control. You can feed a gas range or a clock from these 20 amp circuits. Can I feed the fridge? Bring it on. Yes, anything in the kitchen. So can I feed a receptacle from the outside from the 220 amp circuit dedicated to the kitchen? Circuit cows? No. How about the laundry? No. How about the bathroom? No. Can I feed the receptacle in the bathroom from the circuit coming to the kitchen? No. Can I feed the dining room receptacles from a circuit coming from the bedroom? No. Dining room receptacles will be on the 20 amp dedicated circuit. A receptacle outlet, guys, can be one outlet, duplex, or quadruplex. This is, when you do the calculation, this allocated 180 volt amp. This is 180 volt amp. This one is 2 times 180 volt amps when we do the calculation for that. So this is one receptacle. This is one receptacle. These are two. The quad is considered as 2 receptacles. So if you put this one in this place here, for the sake of calculation, that will be a receptacle outlet. You can, in a receptacle outlet, you can put a quad, a 1 or a 2. Doesn't matter, because then you have to measure from here to here, another 12 feet, and put another outlet. So if you put a quad, that's still a receptacle outlet with a quad on it, or a duplex or a single. But when it comes to calculation, it calculates different. Okay, so now, oops. When it comes to garage, when it comes to, okay. When it comes, guys, to hallways, look how they do the hallways. Every hallway 10 feet or more need a receptacle. Can you guys see that from here to here, 12 feet, you need one receptacle. Should I put it in this wall or in this wall, Chad? It doesn't matter. You can put it, can I put another receptacle? Yup. Minimum. Now look how they measure them though. This is the most important thing. They measure it along center line all the way, as long as you don't go through a door. So here's a door, and here's a door in this hallway. That all with an angle is a hallway. See how they measure it? You go in the center of it. So I have 8 feet here, no receptacle needed. But if you add another 6 feet here, that will give you 14 feet. I need a receptacle. Where should I put the receptacle? Here, 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 or here? Doesn't matter. Any question, guys? Where?
That's just the piece one.
Yes. Now it's a good idea. If I was designing this, I would throw another receptacle here. You know, it's a good idea to throw a receptacle. But what's the minimum? When we design it, you're going to design it, guys, first based on the minimum, then you're going to go also common sense. So if you went and added a receptacle here and you gave it to me, I'll say a good idea. If you added 2 more receptacles here, you might have to question that one. So you're going to use your judgment. You don't overkill. Well, some of you, Matthew, you might look at me and say, Chad, I don't have judgment yet. Right? Yet. It's coming. Then, well, you know the minimum, right? That's it. But you have living, I mean, and then you say, oh, if I'm living in this house, what do I want? How do I want to function? And I'll give you, when you come and redline it, if you're overkilling, I tell you that's overkilling. We talked about this. This is not mostly for you guys. This is for electricians, but if your sink is set back 12 inches or more, if your sink is set back 12 inches or more, then the measurements start from right here. Then this will be 4 feet, this will be 4 feet. So the space behind the sink start counting. Only if it's 12 feet or more. If it's less than 12 feet, 11 and a half, then it doesn't count. Then you start your measurement from here. So the question would be, would this area here count or not? Would it count? Because it will make a difference, right? When you measure, should I measure from here, this way, from here, this way, or should I include this wall? If it's set back 12 feet, 12 inches or more, yep. If it's less than 12 feet, 12 inches, no. So same thing, I think there's another one. How about kitty corner? If it's set up kitty corner, 18 inches or more, then it will count. Can you guys see how we count them? So this area here, would it count? The question would be, would it count? Or should I start my measurement from here and here? Well, what's going to decide is how far is the setback. Is it 18 inches or more? Yup. Less than 18 inches? No. Any comments, guys? So we're getting into the details. We love to test the masters and the Germans on this information. We grill them with it. So on the test, they say 18. They give you a picture like this, and they set it exactly at 18. It counts, right? Less than 18, or they put it 17. Doesn't count. And that makes a difference. Makes a difference is this receptacle exists or not. Now, we're designers. We go above the code. If it was 17, would I put a receptacle there? Definitely. I mean, if you're sitting for a master exam or a German, you would say no. Talked about these. Here's a lighting outlet, guys. Lighting outlet can be a light directly connected to the power or a plugged in. Can I have this one in the basement? I hate it. Can I have an outlet not in the basement? Can I have an outlet in the bedroom? And I switch the outlet, and that will be qualified as a lighting outlet for this area? Yes. The only time you cannot do this is in the kitchen and in a bathroom. You can't use this. It has to be a light. Okay, switched outlet. If an outlet is switched, part of it is switched and part is not switched, then it counts. If it's completely switched, then it doesn't count. So if this receptacle is completely switched, then that doesn't count when you measure the distance from here to here. That will give you 12 inches, 12 feet. That switched outlet is no longer a power outlet. A power outlet. Okay, now apartments. You guys are in an apartment. This is very important because that's actually you're doing an apartment. Everything that we say about the apartment applies. Everything that I told you about the house applies to the apartments, with one exception. Outside receptacles only required on the side that they have a sliding door, an opening door that takes you outside. So if you have a quad and each one of them has a door that opens to the out, not a common door, a door directly from that apartment goes outside, then you have to have a receptacle. The common area, can you guys see that? Common area here? This area is common area. Very, very important. That area here and that area here, common areas, right? Common areas shall not be fed. The code says the common areas in an apartment shall not be fed from either apartment. So you have your option. You either have a separate panel that feeds, I have a light here, I have to have a light. I have a light here and here. I can't feed them from this apartment to that. So either I have a separate panel that feed these lights and a couple of receptacles, which we will be doing. They call it the house panel. So in an apartment, guys, all the common stairways, and if we don't have a lot of common bathrooms in the US, but common stairways, any common outside lights, garages if it's common, all these will be coming from a separate panel. So these two lights here, these two will be going to circuit number 1 from panel number 5, from a separate panel. Done. If I put the receptacle here too, what you guys are going to be doing receptacles, say just for convenience, I take these two, these will be circuit number something. Where did I hide it? Okay, circuit number something. Okay, so that'll be circuit number 2 from panel number 5. Can I guys get you to understand, Karen and Derek, Matthew and Adam, my friends, that you cannot, shall not, will not feed anything coming from any apartment power system. So this apartment, guys, will have its own panel here. This apartment will have its own panel here. And the common place will have a common apartment, common, I don't know, common panel, say, let's just say it right here. So this will be P-1, this will be P-2, this will be here P-5 or -3. Can I get you guys to understand that one? So most of the architects, guys, when you have a quad, what they do is they don't make anything common. So each quadruplex, they have an entrance for each one of these apartments separate. Then you have full control over your separate entrance. You have a common entrance, like this area coming between these two. This light cannot be fit from here or here. Now, if you don't want to have a common panel because you're cutting the cost, you know what they do if you don't have a common panel? What they do is they have one light from this for this tenant and one light from that. So you'll have a light in that common area coming from two lights, one from each tenant, fed from each tenant will feed his or her own light. Unless you have a common panel. This is just the lighting circuits on it. 15. Talked about space, guys, 2 feet or more. Here's a space, habitable space, 2 feet or more. So this is a room, and I have 2 feet or more, then I need a receptacle. 2 feet or more. You need one receptacle. And that's about it. That's all I have about this chapter. Any comments, guys? Any questions? We spent almost 2 hours on it, but it's worth it. There's a lot of information on this chapter, a lot of information. I want you guys to do one little thing for yourself and I. Read this chapter, read it carefully, ask me, because based on the info in this chapter, you're going to be laying out all the project, literally. This chapter has, I would say, 80% of what you need to start laying out your receptacles, your lights, at least your receptacle and lights, and circuit them, based on this chapter. Adam, does it make sense? Okay, that's all I have for you guys. What I'm going to do today, guys, if you Are you guys finished with the setup, or you still need to massage them a little bit? Need more time to do? Okay, so I'm gonna get you today. Keep doing the setup. I would like to look, if you are ready, let me know so I can come and check it and check you for last week. What I'm going to do, walk around and go check all your setup for all of them, make sure they're set to the right layers, and then check you for next week, meaning you're ready to kick the ground. And I want to do one thing together, not today, it's a Monday though, because it will take me longer. I'm going to walk you through how to print 11 by 17. Rescale again, because you set them up right now 22 by 34. We're gonna print half scale 22 11 by 17. That's I'm gonna walk you together with it. So when you guys are ready, I can walk around in a few minutes here and check your work. Okay? Otherwise, if you want to keep kicking the ground on the Monday, you know what the layout is right now. You know what you need to do? Go to the symbols and go to the power and start dropping your power. That's what I'm going to walk you, hopefully, if you guys are ready this week. Thank you.